Good afternoon, guys. Today we are working some more on transformations. This is objective 4.6b. Our topic for today is reflections. We're going to be doing horizontal and vertical flips or reflections, like I said. So your instructional objective, you'll be able to identify and graph the parent function of a given function, identify and perform the horizontal and vertical flips that are indicated, and describe the transformation or transformations in the correct order. Okay, so we're going to start off with the information we put in yesterday's notes, but just so you have it. I'm going to point some things out as you write down your equations there. We have the parent function y equals f of x, whatever that is, and then we have the vertex form of the functions. It's not the perfect vertex form, but it's certainly the transformation form, where you have two numbers that are outside, the a and the d, and those numbers act vertically on your graph. And then you have the numbers b and c that are in the group with your x. And those numbers affect the horizontal actions on your graph. So got it? The numbers that are outside the parentheses affect the graph horizontally. The numbers inside the grouping symbols or parentheses affect the graph. Ooh, did I say horizontally? Oops, erase. The numbers outside affect the graph vertically. The numbers inside affect the graph horizontally. Oh, I almost put that on line wrong. Okay, so remember that you have to do this just like the order of operations. You have to do it in the right order in order to get the correct transformation. So today we will be following these steps. Of course, we will start with the grouping symbols, looking for our horizontal shift, just like we did yesterday. Today we're not doing step 2. We're not doing any stretches or compressions. Today we are adding step 3. The reflections. So we're going to be looking for negations or negatives on our A and our B. So they're going to come into play today. And then, we will still be doing our vertical shifts as well. And this is mostly important when you are describing the transformation. After you do the graph, I want you to write about what happened. So the process is really important for you to follow. Okay, so I provided some steps for you, and I would like to color code these steps. So first of all, today's focus, horizontal and vertical reflections or flips. And I am going to be using the capital H and the capital V to represent the words horizontal and vertical. We're going to be doing that a great deal very soon. We're going to be graphing horizontal and vertical asymptotes and labeling them. And so let's just shorten those words up real quick. So step 1, I'm going to be doing in my pencil. You can choose whatever color you like for step 1. Step 1, when we're given some function to graph in vertex form, the first thing we're going to do is identify the function family and graph the easiest function in that family, which is the parent function. Because most times we can just plug numbers in our head and graph it, and then all we have to do is move it around the graph. Okay? I'm switching colors. I think I'm going to move to blue for step 2. And in step 2, we don't have to fill any blanks because we did this yesterday. Identify the horizontal shift and then shift the parent function horizontally. Step 3, I'm going to switch colors again. Step 3, I'm going to do in another color, my third color. And here is our new thing. This is the thing we're doing today. Look for a negation. What am I looking for? I'm looking for negatives. If A is negative, I'm going to reflect my graph. Okay, so remember the A is in the parentheses or outside the parentheses? Outside. So what affects the graph? Vertically. So it's going to reflect it across the, no, the y-axis is vertical, but if I reflect across the y-axis, I'm moving horizontal. I'm going left to right. Yeah, it's your x-axis. I know that's a tough one. Once we go to the graph, you'll see it a little easier. Okay, if A is negative, we're going to flip it upside down, or take what's down and flip it up. Move the points vertically, up and down. Okay, if B is negative, well, B is inside the parentheses with the X, so it affects things horizontally. So it's going to reflect across the y-axis, left to right, because that's what the y-axis does, right? It splits the graph into a left and a right. Okay, then I'm going to switch to my very last color here, number 4, and I'm going to identify the vertical shift. That's the D term. We did that the other day. And we'll make the final transformation graph the given function. And then I'm also going to do my description in the same color because I'm describing what happened to create the final graph. And we're going to make sure that we do that in correct order. Step 1, then 2, then 3, then final graph. Okay. Alrighty. So let's just do a couple practices with only flips and no shifts. Okay, only reflections. Here I've given you 3 examples, and I'd actually like to add one more that has a double reflection. So I'd also like to graph negative square root of negative x. So I'd like to graph what? Fancy, I know. Okay, so I'm going to start with the parent function of the square root, which is just the square root of x, right? That's the easiest square root to graph. Okay, we remember that the smallest number we can put in a square root is 0. Square root of 0 is 0. Square root of 1 is 1. Square root of 2, we don't know that one. Square root of 3, no. Square root of 4, 2. So you see, that's not bad. We can graph that. Parent functions are pretty basic. Okay, so I'm going to do that one in black. Now, the colors that I'm choosing now have nothing to do with the steps, okay, because I think all of my reflections were in one color. I'm just color coding my graphs to match the equations, okay? So I'm going to do this one in red. So identify what number is being negated here, A or B? A. So that affects my graph how? Vertically, right? So that means I have to flip this over the x-axis because these points have to move vertically. So this point is going to go flip down, upside down. This point is going to flip down. So it's down 2, down 2, down 1, down 1. And then replot. Oh, that's terrible. I'm going to do that again. There you go. So you can see that vertical action. It feels horizontal, right? It's a horizontal fold, but it's a vertical flip because the points are one above the other, not left and right of each other. Okay, so let's do the next one in another color. Okay, so we've got a negation again, but what letter is being negated? The B, and it's inside with the X, right? So that means it's going to be a horizontal effect on the graph. So that means we're going to take all of our points and shift them to the left. So we're going to reflect them to the left. So we're going to go left 1 and then left 1. And left 4 and left 4, and then regraph. All right. Making sense? Any questions? If you have questions, you don't even know what they are yet, huh? Don't even know what questions to ask yet. All right, so let's do this last one here with the double negation, where A is -1 and B is -1. Now, we've already graphed both of these, right? Usually, we'll do the horizontal move before we do the vertical move because we work under the grouping symbols before we work outside the grouping symbols according to the order of operations, right? You work in the grouping symbols before you work out. So our first flip would be left one, right? Across the y-axis. So we're graphing it that way. So we're going to take this purple graph and we're going to do what with it? We're going to flip it over the x-axis. And there it is. So it's a double reflection, which means it's going to totally move a rotation of 180 degrees, basically. So what's happening there? So horizontally, flip left, and then I don't know why it's pushed up, and then flip. Well, in this case, we're flipping down. And there you have it, the 4 examples. Single negations and a double negation. Okay, so let's go and try an actual problem that doesn't just have a negation, but also has your shifts. Okay, so we're looking at the equation g of x is equal to negative quantity x plus 3 cubed minus 2. Step 1 is to, I'm going to color code, so my step 1 was in black, is to identify the parent function. So what family? Is it quadratic? It's a cubic. So the parent function is f of x equals x cubed. That's the most basic one, right? I can see why you think that. It's hard to see the board. Well, on your paper you can see it, right? Okay, so these are easy numbers to cube. 0. 1 cubed. 1 times 1 times 1 is 1. 2 cubed. 8. So 1. Okay, so this one only goes to like 6, 7, 8. So just eyeball it, get it up there. Okay? And then let's reverse that. Let's go -1 cubed. -1 and -2 cubed. -8. And then dashed lines, please. Because this is not what we're supposed to be graphing. It's just the easiest one to graph. We weren't asked to graph it. But we are going to transform it into the graph we were given. Okay, I'm trying to remember my next color. Let me go back real quick. Blue, red, purple. Okay. So now I'm going to go into step 2. So step 2, you know what, I think I'll number these. So this is number 1, and this is number 2. And step 2, what is step 2? Look at your notes, flip it over. Step 2 is to do what? Horizontal shift. So what number in this equation represents your horizontal shift? 3. So the only equation that I'm going to write right now is the equation that includes the horizontal shift. So right now, I'm just going to graph that equation. So I'm building this function that I'm about to graph. And this is telling me to shift which direction? Left 3. So I'm going to take all my points and push them left 3. And you know what? This isn't my final graph. So how about we don't make solid? Because this isn't the answer either. It's just getting us closer to the answer. And I'm keeping track of what I'm doing over here off to the side. This is going to help me in a minute to write my description. Okay, I'm switching now to step 3. In step 3, I think I was doing in red. So what's step 3 of our transformation process? After we horizontally shift, we look for the negation. So that's which term in our original? A or B? A. Was it the B in this situation? No, it's just the A. So I'm going to now add the negation, and I'm continuing to build this equation up here. I don't want the -2 yet, okay? And since it's outside the parentheses, it's a reflection vertically, right? Vertically, because it's outside. So that means everything's going to go across the x-axis. So this point has to go up here because it has to go across the x. This point has to go down here, reflect across the x. This one up here is going to come way down here, and this one way down here is going to go way up here. And again, sketch. We're moving our points. And right now I'm having you do all these sketches. But I know that some of you can hold a lot of information in your head and probably can go straight from the parent function to the final graph. I just want your notes to be really detailed. Okay? Now let's move on to our final step here, step 4, which is our vertical shift, right? Okay, so let me write down that this was a flip. See here, I flipped upside down. Okay, so that was what I did there. All right, now I'm not graphing f of x, I'm graphing finally my g of x, which is my final equation, negative quantity x plus 3 cubed minus 2. So what is this -2? It's outside the parentheses, so it's a vertical action, and it does what? Pushes it down 2. That's right. So now we're going to take our red graph, which is our last graph, and push all those points down 2 spots. 1, 2, and 2. Come on. 1, 2. And I'll take this one down. 2. To 6, because it was at 8. I'm going to take it down to 6. And then this will be solid this time because this is actually the graph. And now we're going to describe what we did, starting with step 1. We took the parent function, correct? So we took f of x equals x cubed, and we did what? Moved it left 3, so we shifted left 3, okay, comma. That was our first step. Then reflected over, okay, I'll write flipped since you said flip. Flipped over x-axis, okay, comma, and finally shifted down 2. And there you have your final description. This is the part where I will be picky in your description. If you can go straight from the parent function to the final graph, I'm okay with there only being 2 graphs on your paper. But I do want your description to be proper. So even if you're doing all of these steps in your head, make sure you're doing them in this order and write it down. Question?
I thought it would have been reflected all the way across the y-axis.
The x-axis?
The y-axis.
Why?
Because it's -2.
This is a shift down to the D term is it pushes the graph up and down. And that's the D term. It's over there on the end. It's the A term, the number in front of the parentheses or the number on the X. Those are the only numbers that'll flip the graph. Okay? C and D only ever push the graph up and down and left and right. A and B are really powerful. They can really change the way a graph looks. C and D don't change the parent function. They just move it around. Okay. Last one. I actually, excuse me, want to change this to a quadratic. Okay, so we have a quadratic. So let's identify quickly what's the parent function of this really wild looking equation. X squared. So first we're going to graph step 1, f of x equals x squared, because it's an easy graph, right? Let's start square numbers. 0 squared, 1 squared, 2 squared, and then of course it's a parabola, so you can just reflect all those nice little points. Make it a parabola, people. Curves, curves. Oh, that was terrible. Okay, so there we have our parent function. Let's transform it. Let's use all our A's, B's, C's, and D's to do what we're going to do. I can't remember what my next color was. I think it was blue. Okay, step 2. So, after we graph the parent function, we look for the horizontal shift. The horizontal shift, which is your C term, right? So, all I'm going to graph is the f of x is equal to x plus 4 quantity squared. Notice that I have not included the negation. I'm just talking about the horizontal shift. And so this 4 tells us we're going to push the graph which direction? Left 4. Left 4, right? Okay, so let's do that. All the points moving to the left 4. Awesome. Draw your graph. Okay. So on to number 3. Step 3 is your negation, right? So this time, which term is being negated? Look at A or B? B. All right, so I'm going to add that number B, negative x plus 4, into our equation. Since it's in with the quantity of x, that means it's going to affect the graph horizontally, right?
Yes.
So everything's going to flip across the y-axis, right? Whatever's over here, we're going to flip over here. I don't want to write the whole word flip, but you get it. So let's take this point and reflect it across the y-axis. So instead of being negative 4, we're going to positive 4. Negative 3 goes to positive 3. Negative 5 goes to positive 5, like that. Negative 2 goes to positive 2. And negative 6 goes to positive 6. There you go. So reflecting it across the y-axis. So you have both of your horizontal moves in there. But someday you'll get to a point, and it might be pretty soon, where you just automatically go to that next step. Step 3. Oh, this cough. I hate it. It's killing everybody. All right, step 4, last step. Last step is to graph our final graph. I think tomorrow we should all stay home. I'll teach math from home. You guys can just sign on. We'll sign on in the morning. You know, we'll get math done early. Okay, so this is a shift up 3. We've gotten distracted here. So now we're going to finally push our graph, use our D term to push our graph up 3 points. So everything's moving up 3. 1, 2, 3. 1, 2, 3. And since this is our original, what we've been asked to graph, solid. And there it is. And then we describe our transformation. We took the parent function, f of x equals x squared, and we shifted left 4, comma, reflected across, using some different terminology here, the y-axis, comma, and finally, was it up 3? Yes, I'm looking at the wrong thing. Shifted up 3. Described. Okay, so tonight you will be working on this part of the assignment that starts at number 19 and goes through number 32. You will have to do 12 transformations and then do 2 fill in the blanks. My requirements are this. For your graphs, you must have the parent function and the final function minimum. And you have to have the description, step by step, no skipping steps.